So you can check the list of registered backends using this function. So you see that there are two backends on my computer. We have the serial backend. So this is for processing things serially. And we have the snow backend. And this is what is being used for parallelization. So these two backends are on my computer by default. So this is what you use for doing things serially without any parallelization. So that means that you're going to execute your tasks one after another, so sequentially. And to create this backend, you can use this function. So it's one of the functions from the VIB parallel package. And it will allow you to do serial evaluation, so serial running of tasks. More importantly, for what we're trying to explain here is this one, so the snow backend. And this one is generated using this function. So this one, as you can see, allows for parallel evaluation, parallel running of tasks. So that's the one that you will find on Windows. On Mac, you will also have this Snow backend, but you will have an additional one. You will also have a multi-core backend, and that one is the fastest. But on Windows, this is the default parallel backend. So SNOW stands for Simple Network of Workstations. That's what you can see here. That's what the acronym comes from. So how does it work, this parallelization via the SNOW backend? Well, it works as follows. So the R session that you're working in now, so your main R session, will create additional R sessions for doing the parallel tasks. And these additional R sessions can be on your computer, but they can also be on other computers if your computer is connected to other computers. Your main R session will have to communicate with these additional R sessions, and it will do so via socket connections. And these are essentially network connections. So if you have data in your environment here, then that data will need to be sent to the additional R sessions that have been created via these socket connections. And also, if you have loaded packages in this main R session, then it means that these packages will also need to be loaded in the additional R sessions that have been created. Starting these additional R sessions and sending the data to these R sessions via these socket connections takes a lot of time. So you should only do this when your data set is so huge that the time that is needed for creating the additional R sessions and sending the data to these R sessions is smaller than the time that you need to process the huge data set in a serial way. So as I said, on Mac, you have the Snow backend, but you also have the multi-core backend. So it is created via this function that also belongs to the BIOC parallel package. And as you can see here, it will also allow for parallel running of tasks. So it works different from the Snow backend because instead of generating additional R sessions, it will fork the current R session. It's a system that is copied from the way that GitHub works. So its forking is a Linux command that clones, that means makes a copy of the original R session. So that means that each cloned R session has access to the original dataset and the loaded packages. So this is a big plus because it means that you don't have to send your data to the cloned R sessions, and that you also don't have to load all the packages in the cloned R sessions. This is all handled. And this is why this is the fastest way of doing parallelization. But unfortunately, it doesn't work on Windows, so Windows users need to use the Snow backend to do things in parallel.